Hi class, today we're going to be going over lesson 5, which is interpreting graphs and word problems. By the end of this lesson, and this is the last lesson in our unit, by the end of this lesson you'll be able to determine and define the y and x intercepts. We're going to go into this in more detail in our next unit, but we're just doing a little bit of an introduction to this topic. You'll understand how to read an equation and determine what the maximum and minimum y value of a function are. By looking at a graph or reading the equation, and you'll be able to interpret and read graphs to determine different pieces of information from them. Where basically this is our application portion. So what we've been doing so far is more knowledge, more understanding, right? You're thinking about how do we find the equation, how do we make a graph from the equation. Now we're basically going in and being like, okay, we know how to do all of that stuff. How do we now use this information from the graph in order to solve real world problems? So just a few reminders from grade 9, grade 10. The y-intercept is where there's only, the y-intercept is when x is equal to 0. It's the point at which the function crosses this y-axis, so this one right here, right? That y-intercept in this situation would be here because that's where it's crossing this line over here. With a parabola and with a quadratic equation, because the parabola only actually hits the y-axis one time, there's only one y-intercept. So in order to find the y-intercept, we know that x is equal to 0, right? Because it's hitting it where x is equal to 0. So we can just plug into the formula x is equal to 0 and then solve for y. How I like to remember this is y-intercept is when x is equal to 0, and in the opposite end, x-intercept is when y is equal to 0. And that makes sense because we're looking for y, so we need to make the other variable in that equation equal to 0, which is y. It's the y and x-intercept. So a way to remember it is if you're looking for y-intercept, you make x equal 0. If you're looking for x-intercept, you make y equal 0. It's just the opposite. X-intercepts in quadratic equations, because they're to a degree of 2, x-intercepts have 3 possible options. There can be no x-intercept, there can be 1 x-intercept, or there can be 2. There's no x-intercept if the graph is shifted vertically above the x-axis. So just a reminder, the x-intercept is when, it crosses this x-axis, right? So when it's going past this line. So if the graph is shifted up above, right? So if it's like this, it doesn't ever actually cross the x-intercept. It never hits that axis, right? So if it's shifted up above and it's actually facing upwards, then we know that there's no solution. So there's no x-intercept in this situation, right? So I'm just going to go in and highlight this in yellow so that we know it's the yellow one. Or in case it's shifted down and it opens downwards. So if it opens downwards and is shifted down below the x-intercept, so I'm actually going to write that in as well. Or shifted down and facing up. Facing down, sorry. So just like that one over there. So those are 2 options that we have, right? You'll have 1 x-intercept when the vertex is on the x-axis. So say there's no vertical shift. So we'll say no vertical shift, right? And it's just lying there on the original x-axis. So it'll look something like, and I'll just do this in green so that we can see it. Right, it looks something like that. That's what would have 1 y-intercept because it only hits the x-axis at that one point, right? And then last but not least, which is the diagram we have here, I'll just put this in blue so that we can see it a little bit more clearly. In this situation, you'll have 2 solutions, and that's because the x-intercept it's shifted below the axis, or another time that you could have 2 is say it's opening downwards, right? And I'm sorry, this is starting to look a little bit messy, but if it was something like this, right? So shifted upwards, but it's facing down, right? or shifted up and facing down. Right, that would also be a possibility where you could have two y-intercepts. To find the to have two x-intercepts. To find the x-intercepts, like I said, if you're looking for the x-intercepts, the y is going to equal 0, just the opposite. And then you're just going to solve for x. One important thing to remember, and I don't know if this is, and we'll talk about this a little bit later, when you square root a number, there's always two answers, a positive and the negative. And the reason that is because if we think about it, if we had 4 and we square rooted this, you could have plus 2 or minus 2. Right? We usually just write 2, but we also need to remember that negative 2 squared is also 4. Right? And then 2 squared is also 4. So that's just important for us to remember because it starts to make a difference in this situation just because we can have either a negative x or a positive x. So when we were doing trig and we were doing square roots, we just left it as a positive. And the reason we left it as a positive is because you couldn't have a negative side length. But now you can have a negative point. You can have a negative x value, so you do need to write in both possibilities. All right. So we're just going to do a few examples together. We're going to find the x and the y-intercepts of the following equations. We're going to do 3 examples together. Again, I'm going to go through one with you. These all have different solutions. So one of them has one solution, one of them has no solutions, and then one of them has 2 solutions. So we'll go through how to find all of those. If you would like, you can try these on your own, see if you can figure out which one has which, right? So pause the video here and try it out. But there's definitely going to be opportunity to practice when we move on to our word problems, okay? So let's do the first one together. We're going to do y is equal to half x plus 6 squared, right? Let's just go in and find our y-intercept first. It's just the easiest one to do. So I know when I'm looking for my y-intercept, x is equal to 0. So I'm just going to go in. And for y equals 1/2 x plus 6, I'm going to plug in. I'll just write this in. So plug in x equals 0 and solve for y. Okay, so let's do that. So we have y equals 1/2 0 plus 6 squared, right? And lucky for us, we can just go ahead and do that. 0 plus 6 is just 6. Y equals half. 6 squared is 36, right? Always do the squared first, and then let's do our half. 1/2 times 36 is 18. So I know y is equal to 18, right? And I'm going to just write the coordinates. And I know x is equal to 0 because we already had determined that. So we have 0, 18 is our y-intercept. Therefore, y-intercept is 0 and 13, right? So if I wanted to go plot that into the point here, I would just go up to my graph and say, okay, 0 and 13, so it'd be up here somewhere. That's where my y would intercept. Okay? Easy peasy. Let's go on and do our x-intercept. So I'm just going to move this over here a little bit just so that I can solve for my x-intercept. So I'm just going to move it over here. Because I just need the space to do the next one. So let's go on and do our next one. So I know that at the x-intercept, so I'll do this in this pink pen over here. At the x-intercept, y is equal to 0. So what I'm going to do is I'm going to plug in 0 for y and solve for x. So let's do that. So I'm going to do, all right, I have y is equal to 0. So I'm going to say 0 equals 1/2 x plus 6 squared. Right, so I'm going to multiply both sides by 2 just to get rid of that 2 at the bottom. So 0 times 2 is just 0. So I got rid of this half, got rid of it. So I'm left with x plus 6 squared. Now I want to get rid of that squared sign. So I'm going to do square root on this side, and whatever I do to that side, I got to do to this side. So technically it should be plus minus 0, but since it's 0, there's no plus minus, right? And I'm left with x plus 6. So then I want to get x by itself. I'm going to minus 6 on both sides. And 0 minus 6 is just negative 6. So negative 6 is equal to x. And I know my y is already 0. So my point is, therefore, x-intercept. This only has one solution. X-intercept is 0, 6 and 0. Or negative 6 and 0. Right, and it's important to have that negative because it's shifted, and that makes sense. Because it's positive 6 here, we know it's shifted to the left by 6, so it makes sense that the vertex would be negative 6 and 0. Okay, so let's try and do A, obviously a little bit more complicated because we have a little bit more shifts going on. So now I know that this is going to be facing downwards because it has a negative 3 value here. Right? So it'll be facing downwards and it's shifted down by 7. So if I go back here and I look at my graph, one of the things is there's no x-intercepts if it's shifted down and facing down, right? Shifted down, facing down. So we're going to have no x-intercepts. The way that you can solve for this, I'll show you how you can see this mathematically. Sometimes you might not see it right away, and you can do it mathematically and figure out why that is. So first things first, let's find our y-intercept. It's going to have a y-intercept naturally. So let's go find our y-intercept. Y-intercept equals when x is equal to 0. So I'm going to go in, do that. Right, so we have y equals negative 3 x minus 2 squared minus 7. And I'm just going to replace the the x with a 0, right? Because we're looking for the y-intercept. So let's go replace our x with the 0. So now let's just do the math. We're going to solve for y. Negative 3, 0 minus 2 is just negative 2 squared minus 7. So then we're going to go do our squared now. Negative 2 squared is positive 4 minus 4, right? We're just making sure we're using BEDMAS. Then you got to do multiplication. So we did brackets, exponents, multiplication. So we have negative 12 minus 7. Y equals negative 12 minus 7, which I know is negative 19. So I know that the y-intercept is x is equal to 0, negative 19. Now let's go find our x-intercepts. Even though we know we're not going to have them, I'm going to show you how to do this mathematically. You're going to do the same thing. You're going to say x-intercept is when y is equal to 0. And we're just going to solve. And you'll see why you'll get no solution. Minus 2 squared minus 7. Right, so I'm going to bring the 7 over to the other side. It's going to become positive 7. So I'm left with negative 3x minus 2 squared. Right, I want to get rid of that negative 3 in the front. So I'm going to do divided by negative 3 divided by negative 3. So then I'm going to say, okay, I'm left with 7 over 3. So it's going to be negative 7 over 3 equals x minus 2 squared. In order to get rid of that square root sign, or that squared sign, I'm going to square root both sides. You can't do this. So if you put into your calculator negative 7 over 3 square root, you would get something that said math error. It says math error. And the reason it says math error is because you can't square root a negative number. It's not possible. The reason that is because when you have a negative times a negative, it's always going to give you a positive. So there's no way that you could have even had a value that was negative square root in the first place. So because this is a negative, -7/3, no roots or no x-intercepts. And this makes sense because it opens down and is shifted down, so it never crosses the x-intercept. It never crosses the x-axis. Okay? And that's how you would solve that. Alrighty. So let's go on and do this one. We're going to do the same thing. We're going to find our y-intercept, our x-intercept. Right, so this one, we're starting off with our y-intercept just because it's the easiest one to find. So let's do y-intercept. Right, is when x is equal to 0. So let's put that in. Y equals 0 squared minus 4. Y is equal to 0 minus 4. Y is equal to -4. So therefore, y-intercept is 0, which was our x, and -4, which is our y. Let's do the other side. Let's do the x-intercepts. Again, here y is equal to 0, so we're just going to go plug in our values. 0 equals x squared minus 4. We're going to bring the 4 over to either side, so I'm left with +4 x squared, and I'm just going to square root both sides. So remember when I said in this situation, it would be plus minus the square root of 4, which is, I know if I square root 4, it's going to be 2, is equal to x. So therefore, because that is a positive value, the 4, and it's a non-zero value, we know we're going to have 2 x-intercepts. The other reason we would know that we had 2 x-intercepts is because if you think about it, this is -4, so it's shifted down 4, right? But it's facing up, so it's shifted down 4. So if I go back here, it's shifted down 4, and it's facing up, which makes sense that it would cross the x-intercept at 2 different points. Right? So therefore, x is either 2 and 0 or -2 and 0. It's just the positive value and the negative value of the same number is going to be the x. Okay? And that's the answer for that. So let's do a few word problems together because, again, these are obviously more complicated, and this is what we're ultimately aiming for. We're trying to find out, can I solve these word problems? Okay? So let's go in and do this word problems. It says a flare follows the height given by equation -5.25 times t minus 4 squared plus 86, where h is the height of the flare in meters, so that tells us how high off the ground the flare is, and then t is time, how long it's been since we've shot the flight path. So I actually drew out the equation for you already, but we will find a table of values. It says draw a graph of the relationship using a table of values, so let's draw in a table of values. It just was too hard to draw out, so I just gave you what it would look like, but we can do a table of values together. So it says from times 0 to 8. So those are the times we're going to use because they gave us the domain or the times that we should use. So let's do 0. Right? And I'm just going to plug in t for whatever it is here. So I know height is equal to -5.25 times 0 squared times t minus 0. Or 0 minus 4 squared plus 86. And if I do that math, I'm going to get 2, right? Keep going. I'm going to do -5.25 times 1 squared plus 86. And I just throw this in all together. And I should get 38.75. And I'm just going to go ahead and do that all for the next. So I'm going to get 65. Then I'm going to get 80.75. Then I'm going to get 86. Then I'm going to get 80.75 again. Then I'm going to get 65. Then 38.75. And then 2. Right? So if you go here, you can actually see that that's what's drawn in. You start off at 0, 2. Right? You go up to 2 and you're at like 65-ish up here. So they just plotted it for us. I'm not going to bother doing that. It's just too much to go in and plot them individually. So I just gave you the graph. So we've drawn the graph. What is the maximum height reached by the flare, and when does it reach this height? So let's look at it. So we have this graph, right? And we have this little flare going all the way up, all the way up, all the way up, all the way up. And then it gets to this point here and turns around and starts to fall back down. Right? So this is the maximum height that it'll reach at time 4. So if we go and we look at the time 4, the maximum height it will reach is 86 meters at 4 seconds. And we can find the maximum that it will reach by just looking at the vertex of our graph, right? The point at which it turns around is the maximum height it will reach. And the maximum height it will reach is 86 meters at 4 seconds. So I'm just going to go write that in here. So maximum height is k value of the vertex, right? Because we know that, because the maximum height is a y value, so it's a k value of the vertex. So our vertex is 486. Therefore, max height is 86 meters at 4 seconds. And this is more just an understanding is, do you understand what the graph is asking you and what it's telling you? So you just go and you look, okay, time is 4 seconds. What's the highest point it can reach? 86. So I know that's my maximum. Less math, more reading into the graph. Okay, so C is asking us, what was the height of the flare when it was fired? So I'm asking myself, okay, where did the flare start? And I can do this by saying, I know the time when it started. I don't know what the height was, but do I know the time? Yeah, I do. When we fired the flare, the time was 0. So I'm going to say, okay, when we fired the flare, t was equal to 0. So we're looking for, oops, sorry about that. So we're looking for y when, or sorry, h when t is 0. So let's just plug in the value into the equation. So let's say, okay, h is equal to negative 5.25, which is equal to t, and then that's t minus 4 squared, plus 86. So I'm just going to go sub in t and change this t to 0. Right? And I'm just going to solve for h. So I have negative 5.25. 0 minus 4 is just negative 4 squared plus 86. So then I'm going to do h negative 5.25 times 16 plus 86. H is equal to, I'm just plugging that in, so negative 5.25 times 16, I know is negative 84 plus 86. Negative 84 plus 86, height is equal to 2. And we know it's in meters. Therefore, at the time of its launch, right, when t is equal to 0, the rocket was at 2 meters. Right, and we know that because It's just more of like interpreting, like what do you actually understand from this graph? We know that the height of the flare when it was fired, we're trying to find that out. So I need to find out the time that it was fired. And if I know that, then I can figure it out. And we're going to use that same logic kind of for D over here, right? Where it says after how many seconds after it was fired, did the flare hit the water? So now I'm going, okay, it went up, it went up, it went up. It reached its maximum height. It's coming back down, it's coming back down, right? At what point does it hit the ground, right? And it's still going. It's going past this point. So let's figure that out. At what point did it hit the ground and hit the water to the nearest second? And how we can figure that out is the point at which it hit the water is when the height is equal to 0, right? We know that at 8 seconds when it hits it over here, it's still at 2. But we want to find out, okay, just a little bit past 8 here, you can see it's not at 8, it's just a little bit past 8 here, right? The flare hits the water at some point, and we want to find out what that point is. And how I can do that is I know that it's going to be when the height is equal to 0. I'm trying to find time now, so I need to know what the height is. The height is 0, so let's find time. So let's find time when height is equal to 0, and we can do that really easily. We just need to plug in 0 for our h value. So 0, I'm going to write the equation out again just so that you remember what it is. Our equation is negative 5.25 t minus 4 squared plus 86 is equal to height. So I'm just going to go plug in 0 for my height and solve for t. So I'm going to get rid of the 86 on this side, move it to the other side. 0 minus 86 is going to be negative 86. T minus 4 squared. Get rid of that negative 5.25 by dividing it on both sides. Negative 86 divided by 5.25 is going to leave me with 86 because these two negatives will cancel out. 5.25, and you can put this as a fraction, you can leave it as a decimal, it doesn't matter to me. And I'm left with, since these two canceled out, I'm left with t minus 4 squared. I want to get rid of that squared sign, so I'm going to do square root on both sides. When I square root this sign, I need to remember that whatever the answer is, it's going to be plus and minus. So I just like to put in my plus minus right away. Right, so I'm going to do square root of 86 over 5.25, and that for me is 4.473, so I'm going to leave it as 4.05 is equal to t minus 4, and I need to remember that it's plus or minus. So this is where this gets a little complicated, and I'm going to just split it up into two options. So let's do negative 4.05 equals t minus 4, and isolate for t this way. So I'm going to do negative 4.05 plus 4 is equal to t, and that's actually negative 0.5, or 0.5, sorry. On the flip side, let's leave it as a positive. Positive 4.05 is equal to t minus 4, so I'm going to bring the 4 over, so it's going to be 4 is going to give me t. So I'm left with 8.05. This answer just makes sense. You can't have, there's no such thing as a negative time. So we actually just ignore this. So we know that the answer is the time at which the flare hits the water is 8.05 seconds. And that's my answer. So now that we've done that, right, I'm going to have you try doing example 2 on your own. So pause the video here. This example is saying the path of a ball is modeled by the equation y equals negative 3x minus 1 squared plus 12. That's what it's asking. Where x is the horizontal distance in meters. So like when you're throwing a ball, right, it travels vertically, so it goes up a certain amount, and then it also goes horizontally a certain amount. So I'm just going to draw out a diagram of what that looks like. Right, so I have this ball. I'm over here. And I'm going to throw it from here, and it's going to go up a certain distance and horizontally a certain distance, right? It's going to travel along here, and it's also going to go up to some certain height. Okay? Y is a meter is above ground. So draw a parabola using transformation. So we're going to use the stuff that we've been using with x minus 1, ay plus c, or ay plus k. Then we're going to find out what the maximum height the ball reaches is, as well as its horizontal distance, right? And then we're going to find out at what horizontal distance does the ball touch the ground, and then we're going to find out at what height is the ball 1.5 meters from the person horizontally. Okay? So let's just start off with the easiest one. It says draw a parabola using transformation. So we're going to do, I'm just going to remind you what our general formula for x squared is. It's -3, -2, -1, 0, 1, 2, 3. And this is why I said you need to remember this stuff even after you write the quiz, because even though it's not directly something we're doing, it's always going to be something we're using, right? So let's go draw in our transformation table. It's going to look something like this. So I'm going to say x. I'm going to go find my k, h, and a values. So my h value is going to be +1, right, because I just took it from the middle. My a value is going to be -3 from the top. And then my k value is going to be +12 from the end. Okay, so then I'm just going to say, okay, I'm just going to go plug in what I know. So my h value is +1. My a value is going to replace that with -3. And my k value is 12. So let's go in and put in our original x's, which are -3, -2, -1, 0, 1, 2, 3. Our original y values, which is 4, 9, 4, 1, 0, 1, 4, 9. And let's go plug in what we need to do. So for x, we need to add 1 to everything. So -3 plus 1 is -2. -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1 is 1. Plus 1 is 2. Right? And those are our new x values. Here, we're going to multiply everything by -3, and we're going to add 12. Which is going to give us -15. -3 times 4 is 12. Plus 12 is just going to be 0. -3 times 1 is -3. Plus 12 is going to give us 9. -3 times 0 is going to be 0. Plus 12 is going to be 12. -3 times 1 is -3. Plus 12 is going to give me 9. -3 times 4 is -12. Plus 12 is going to give me 0. And then -3 times 9 is -27. Plus 12 is going to give me -15. Right, so now I have my new x's and my new y's, so I'm just going to graph those in. So I like to go up by, I actually went up by 1s here because I had enough space, because I gave us a bigger graph to work with. I'm just going to go draw in my graph here. And I just didn't go any further because I know I'm not even going to go that far down, so I just left it. So then I'm going to go up here and I'm going to say, okay, at -2, my graph goes down to -15. So I'm just going to draw a point in there. At -1, it's at 0. So I'm going to put a dot there. At 0, it goes up to 9. So I'm going to put a dot there. And then at 1, it goes up to 12. So I'm just going to throw in a dot there. At 2, it goes down to 9 again. So I'm going to put a dot there. At 3, we have 0, and then at 4, we have 15 again. So then I just like to sketch in my graph. Okay, so we have our graph here. So we're done A. It says draw the parabola. We're done that. Determine what the maximum height the ball reaches is and what the horizontal distance is when it occurs. So when it's asking for a maximum height, it's just asking for the vertex, right? So our vertex here is what? Let's go look at it. Where is our vertex? It's right here, right? So I'm just going to put that in green. The vertex is, and you can find that by looking at the graph, at the equation 2. We know that the vertex is HK, right? And we know that H is 1 and K is 12. So we know it's 112 there too. The vertex is 112. So we didn't have to draw it in. I just did because it was easier. So therefore, the maximum height is at 12 meters. And the max occurs at the one thing to remember here is you can't actually have negative times or negative distances. So I'm going to actually get rid of this part of this graph, right? And the only part I'm going to keep is up until about here. Okay? And there's a reason for that, and we'll talk about why that is. Sorry. That's why it gets a little bit complicated when you draw these graphs, just because of where. I'm just going to delete everything other than 0. Okay. And it occurs at a horizontal distance of 1 meter, right? The maximum height happens at 12.1. So that's when it occurs. Cool. And you could honestly figure that out from here as well. If you looked at your table of values, you could see that the maximum height that it reaches is 12 meters. So that would be that. The other thing you need to remember is that you can't have a negative distance either in height. So you would have to draw this graph. I just like to draw them all out, and then I like to get rid of the stuff that just doesn't logically make sense anymore, because this is probably when it would hit the ground. Okay? So moving forward, we're going to say, okay, what is the horizontal distance? At what horizontal distance does the ball touch the ground? So we kind of already have it from our graph, right? We kind of already have it from our table of values, but for the sake of clarity, let's just try to find it mathematically as well. So I know that the horizontal distance at which it touches the ground is when the ball goes all the way up and it comes and it hits the ground. The height then is going to be 0, right? So if I'm looking at this logically, I'm going to go in and say, okay, y is going to be equal to 0 because that's what the height is. So y is going to be equal to 0. What is x? Right? So let's find that out. So it's going to be -3. So y equals -3. X minus 1 squared plus 12. Right? I'm just going to replace that y with the 0. So let's find that. So it's going to be 0 equals -3 x minus 1 plus 12. I'm going to carry the 12 over to the other side. So I'm going to do 0 minus 12, which is going to give me -12. equals negative 3x minus 1 squared. Get rid of the negative 3 on both sides. Negative 12 divided by negative 3 is just going to give me positive 4 is equal to x minus 1 squared. Right? I want to get rid of that square root sign, so whatever I do to this side, I have to do to this side. And I need to remember that because I'm square rooting, it's always going to be plus minus. So I'm going to have plus minus 4 is equal to x minus 1. So I'm going to split these off into two different solutions. Right? So I have negative 4 equals x minus 1. And then I'm going to say, okay, if I have positive 4, what's x minus 1? So let's carry the 1 over to the other side, to get the y by itself. So it's becoming negative 4x plus 1, negative 3 equals x. And then 4 plus 1 equals x. Right? Oh, sorry. It shouldn't be plus 4, it should be 2. Silly mistake. Either way. Because you're taking the square root of 4, right? So then you have 2, negative 2. Negative 2 plus 1 is just still going to be a negative number. It's going to be negative 1, right? And then I was like, that doesn't make sense. That's not what's on my graph. 2 plus 1, right, is going to give me 3. So I know x is 3. I can't have a negative distance. It has to be positive. So I can just ignore the x minus 1. That's something we call inadmissible, right? I can ignore that. So I know that my x is going to be 3, which makes sense because here we can look from the graph. When it hits the ground, it's going to be at distance 3. So I'm just going to write that in. Therefore, the distance at which it hits the ground horizontally is 3 meters. Okay. That just looked better. All right. So we're done A, we're done B, we're done C. Let's do D. It says, at what height does the ball have a horizontal distance of 1.5 meters? So if I'm asking for a horizontal distance, I know that x is going to equal 1.5 because that's what represents the horizontal distance. And I want to know at what height. So let's say y is equal to what we're looking for. Y is equal to question mark. So let's find out what y is equal to when x is equal to 1.5. And this is pretty easy. You're just going to put it back into the equation. You're going to say y is equal to negative 3 x minus 1 squared plus 12. And I'm just going to go in, replace my x with 1.5. Right? So it's going to be y is equal to negative 3. 1.5 minus 1 is going to be negative 0.5. Right? Or 1.5 minus 1 is just 0.5, not negative. 0.5 squared plus 12. And then I just go and do the math. So it's going to be negative 3 times 0.5 squared, which is negative 3 times 0.25, which is going to give us negative 0.75 plus 12. Right, and then just add 12, and I know that y is equal to 11.25 meters. So I know that at a height of 11.25 meters, the height, therefore, the height is 11.25 at 1.5 meters. Horizontally, which if I go here makes sense. It's going to be like right here, right? So it's about 1.25. And that's it. That's the end of our lesson on interpreting graphs.